So these notes are on gases. We've done solid, liquids, and gases, and we talked about the transition between solids, liquids, and gases. These are just going to be on gases. That's going to be our whole next unit. Realize that when you're taking these notes, you could obviously use your phone to watch this video and take your notes on your iPad. Or if you're updated, you can scroll that screen up and you can open up YouTube on a side panel, and then you could watch the video over here, right? And then take the notes over on the left if Notability is open. It's up to you however you want to do it. So moving on, right? Just some real general properties about gases that we really already have gone over. One of them, make sure you realize that gas does have mass, right? If you talk about the air in the room, that's oxygen and carbon dioxide and nitrogen. Well, we know that oxygen is a diatomic atom bonded to itself, and it has an atomic mass of 16 AMUs, or 1 mole of gas weighs 16 grams. So it does have mass. It's even though it's kind of floating around the room, right? It does have mass. Another general property, right, that we know that gases can be compressed, right? We put them in tires, basketballs, volleyballs, things like that. We know that if we have a gas in a confined container and we heat it up, it could explode. So gas can be compressed into whatever volume we want it to be in, right? And because it can be compressed, it also will expand, right? It fills the container it's in, whether that container is a basketball or whether it's our classroom, the gas will always expand to fill up the container. They can easily travel through each other. So an example right there is wind, right? Or even when you're talking, you're blowing air out your mouth, right? Well, you have a room full of gas and you blow out, and obviously that air, that air moves through the air that's already there. Unfortunately, if someone's got bad breath, right, all of a sudden you can smell the bad breath because that air is moving through, that gas is moving through the gas that's already there. And the last one, gas exerts pressure, right? And that's what we put in gas in things like tires and basketballs and balloons. And because we put in more of that gas, there's more particles bouncing around to exert pressure. And so we can blow up that balloon, right? Pressure from a gas is simply every time a gas particle, because they're randomly moving around, right? Every time a gas particle, as it's randomly moving around, hits the side of its container, when it strikes the side of the container and bounces off of it, that's where the pressure comes from, when it hits the container and bounces off. Okay, the kinetic molecular theory, right? Well, it kind of goes through a lot of those a lot of those properties that we talked about, but you need to know that they're part of the kinetic molecular theory. So one of those is gases have mass, right? The other, gas particles are widely spread apart. So basically, that talks about it taking the shape of the container, it fills up the container, it can move through each other, all those kind of properties that we talked about. The next one, gas particles must be in constant rapid motion. So that's the part that causes the pressure that I was talking about, right? If they're in constant random motion, if they're always moving around and when they hit each other, they kind of bounce off of each other, then when they hit the side of the containers, they exert pressure, which brings us to our next one, right? Gas particles exert pressure because they frequently collide with the walls of their container. Now, I guess I should have said this earlier, but if I'm going so fast you can't fill in the notes, obviously that's why there's a pause button, right? You can pause it and fill in the notes and keep going. So gas exerts pressure because they frequently collide with the walls of the container. I've explained that. Our next one, right, that we talked about last unit, the average kinetic energy of the gas particle depends only on the temperature, right? Kinetic energy is really an energy of motion. So the faster our gas particle moves, the more kinetic energy it has, and we basically measure that energy by saying it's the temperature, right? We called it thermal energy in our last unit, which really is just a more specific way of saying it's the kinetic energy of a gas particle. And our last one for the kinetic molecular theory, right? Gas particles are not attracted or repelled to each other. So why that's important is that means that when a gas particle is randomly moving around and it comes close to another gas particle, it's not going to curve or be attracted to it. It's just going to keep moving in a straight line. And if it does happen to run into another gas particle, it just bounces off of it like this perfect collision, this perfect bounce where it doesn't slow down or anything. It just kind of keeps going. So it might change direction then because it bounces, but it still doesn't slow down, which means if it doesn't slow down, then it's keeping its average kinetic energy, which means that gas is staying at the same temperature. So we're going to make various calculations with gases. We're not going to necessarily get into all those calculations in these notes. There's different gas laws that we're going to be talking about. But within those gas laws, we're going to talk about 4 different variables, 4 things in gases that can change. Or that affect how a gas behaves. So one is the amount of gas, right? Well, we're not going to measure it in particles, we know, because there's so many particles in really in anything, right? Because atoms are so ridiculously small. So what do? We measure amount in moles. So anytime you have anything where they give you an amount, like a mass of something, we can convert it into moles, and then we know how many particles of gas we have. When you see it in an equation, that symbol is going to be a lowercase n, not a capital N, but a lowercase n. Then if we look at an example like this, right, if it said how many moles of nitrogen gas are in 4.72 grams of N2, well, we need to convert that to moles because we want to measure amount in moles, not in mass. So we're going to use our conversions that we learned at the beginning of the semester, right? We want our units of grams to cancel out. And so the molar mass of N2 is 28. So 1 mole, right? 1 mole equals 28 grams. And so our 4.72 divided by 28 gives us the amount of our gas in moles, right? We'd have 0.169 moles of N2. And you can see that I went to 3 sig figs just like our initial number had 3 sig figs. Our next variable, right? Volume. Well, we know that it's going to take the shape of the container, and we also know that it's going to fill up the container, right? So it's going to completely and evenly fill up the container. So that means that the volume of the gas is the volume of the container. So don't get confused on that, right? If they say, oh, it's in a 1 liter bottle, well, that means there's 1 liter of gas, right? If it's in a, if you have talking about an empty thing of a 2 liter bottle of soda, right? If it's empty, it's not really empty. There's air in there. And how much air? Well, you have 2 liters of it because it takes up the shape of that container. So the symbol for volume is a capital V, not a lowercase v. A lowercase v, right, is for velocity, but a capital V is for volume. So make sure you use that capital V for volume. Remember, lowercase n for moles now, capital V for volume. And we always want to measure them in our standard, and our standard is liters.